So I recently watched a video about by 3 Blue 1 Brown about Pythagorean triples. In it, he talks about a certain formula that can be used to generate Pythagorean triples. And the formula looks like this, and you plug in a certain value for u and v, and the formula will give you three numbers that satisfy the equation a squared plus b squared equals c squared. I thought this was a really cool formula, and I wanted to see if I could extend it to 3 dimensions. In 3 dimensions, instead of using this formula, you use the formula for 3 dimensions, a squared plus b squared plus c squared equals d squared. And the goal is to make a formula that can generate 4 numbers, a, b, c, d, that satisfy the equation. So, if you were thinking about this problem, you might think about these 3 numbers and what all the possible values that the sum might have. And you might think about how changing the value of a or changing the value of b affects the overall sum, and how that affects the value of d at the end. But thinking about all the possible combinations of 3 square numbers and how they might all sum together is a bit difficult to think about. So one thing that you might try to do is to reduce these 3 numbers into 2. And one thing you might try to do in order to reduce is to move the c squared to the other side. It doesn't look like we've changed anything, right? Because we've only moved one term to the other side. We still have 4 numbers to worry about. But this is actually important because we've rephrased the problem into what 2 square numbers will add up to be the difference between 2 other square numbers. We've rephrased the question. And actually, I haven't even said what the inputs and outputs of the formula are going to be. What exactly are we going to be inputting? Well, from this, what you might think to do is to make a and b the inputs. So a and b is what you input, and d and c becomes the output. This might be something you could think of. It's pretty reasonable. It feels like it should work. You plug in a value for a and b and you get out a value for d and c. But this doesn't work because if you specify a certain value for a and b, there's actually multiple values for d and c you could have. So if you want to narrow in on a certain singular Pythagorean quadruple, you have to use a third input to specify which values for d and c you want. Because if you only give the formula a and b, there's multiple values for d and c and the formula doesn't know which one to give you. You could try making a formula using only 2 inputs, but that formula would have to give you multiple outputs for d and c, which I think would be complicated. So you need a third input. And by rephrasing and this is where rephrasing the equation becomes important, because what we've just done is written it as a squared plus b squared equals d squared minus c squared. And you might think to specify, if you're lucky, you might think to make the third input to be d minus c, because what you're essentially doing is specifying what the difference between d and c must be. And by specifying the difference between d and c, you also narrow down the difference between d squared and c squared. And that also helps narrow down what d and c the formula will give you. So now with this third input, the formula knows which values of d and c to give you based on this third requirement that you've sent in. So to reiterate, we're going to be having 3 inputs, a, b, and delta, to specify which values c and d we want as our outputs. Okay. So now what? We have one equation, a squared plus b squared equals d squared minus c squared. And oh, I forgot to say, delta is going to be set to be equal to d minus c because I don't want to keep saying d minus c every time. So it's going to be called delta. So delta is equal to d minus c. So this is one equation. And our other equation is delta equals d minus c. And this is actually a system of two equations because think about it. A is an input, B and delta are all inputs. And because they're all inputs, you can think of them as constants. And then D, C are your outputs. So you have two equations and two unknowns. You have a system of two equations. And you can use substitution. So rewrite this equation to be d equals c plus delta. And what you can do now is substitute it in for d. So now it becomes c plus delta squared instead. You can multiply this out, and the c squareds will cancel, and you'll end up with this, a squared plus b squared equals 2c delta plus delta squared. You move the delta squared to the other side, and you divide both sides by 2 delta. I've made this a little confusing by reversing the equation. You see, this side has actually gone over to the other side of the equation. It hasn't changed anything, I've just reversed it, but it might be a bit confusing to look at. And this c has also come over here instead. Hopefully you can figure out what I've written here. So anyway. So we end up with two equations as our formula. That's it, that's the formula. Because we've just solved for c. By dividing by 2 delta, we've gotten this. Where you plug in a value for a, b, and delta, and you get out a value for c, which you can then plug into this equation to find the value of d. And this equation, by the way, came from over here. So those are the two equations that make up our formula. It's relatively simple, and to see if it works, we're going to test it. So first we're going to try a equals 1, b equals 2, and delta equals 1. So c is going to be equal to 1 plus 4 minus 1, right? 1 squared plus 2 squared minus 1 squared over 2 times 1, 2. C is equal to 2. D is equal to c plus delta, so it becomes 2 plus 1. Right? D is c plus delta, c is 2, so D is equal to 3. And the quadruple we get out is 1, 2, 2, 3. 1 squared plus 2 squared plus 2 squared equals 3 squared. Let's see if this works. 1 plus 4 plus 4 equals 9. Yes, that's true. So this formula does work. Let's try it with a bit more complicated ones. Maybe we can try a equals 2, b equals 4, delta equals 10. Let's try 10. C is equal to a squared plus b squared minus delta squared, 4 plus 16 minus 100 over 20. Okay, I think we're gonna get a crazy fraction this time. So it's gonna be 4 plus 16. I think I've done this correctly, right? A squared plus b squared minus delta squared, 4 plus 16 minus 100, divided by 20. And we get negative 4. Not to worry, it's negative 4. But it'll get squared anyway, so that's fine. D is going to be negative 4 plus 10. So it's 6. And actually we might go ahead and make this c equal to positive 4 because it's going to get squared anyway, so it doesn't really matter. 2, 4, 4, 6. You might realize that I've used the negative value of c when I'm making d. That's because the formula is given -4, so it wants me to use -4. So I have to use the value of -4 to get d. But once I've gotten all the values a, b, c, d, the ones that are negative, I can make positive, and that doesn't change anything because making a negative number positive doesn't change what its square is. So I can do that. So 2, 4, 4, 6. That's what it looks like. So let's just test this out. Just to be quick, I'm gonna put in here 2 squared plus 4 squared plus 4 squared, and that is 36. So that works. I wanted to test something out, but we got all clean numbers, so I can't really test that. So let's try some other numbers. Let's try some crazy ones. Maybe a equals 3, b equals 7, delta equals 5. I want to show you what happens when c is a fraction, so hopefully we get a fraction here. So c is a squared, 9, plus b squared, 49, minus delta squared, 25, over 2 delta, which is 10. Right, I'm just going to remind you what the formula is if you didn't follow me. A squared plus b squared minus delta squared over 2 delta. Okay? 9 plus 49 minus 25 over 10. So it's 9 plus 49 minus 25, over 10. Yes, got a fraction. Good. I don't think I've ever been this happy to get a fraction. But this is good because I can show you what happens when you get fractions. So 33 over 10, and d is equal to 33 over 10 plus 5. Okay, so let's just make d a single fraction. So 33 over 10 plus 50 over 10, right? 5 is 50 over 10, I haven't changed anything. Then you get 83 over 10. So our quadruple looks like 3, 7, 33 over 10, 83 over 10. Now this isn't a satisfying quadruple because they're fractions. You want them all to be integers in order for that to be a satisfying quadruple. So let's see if we can make them integers. 3 squared plus 7 squared plus 33 over 10 squared equals 83 over 10 squared. The reason why I'm writing it as an equation is so I can show you how to make all of these numbers integers. So this is the equation, right? And what I'm going to do is multiply both sides by 10 squared. Actually, I don't need this anymore, so we're going to multiply both sides by 10 squared. So it's going to be 3 squared times 10 squared plus 7 squared times 10 squared plus 33 over 10 squared times 10 squared equals 83 over 10 squared times 10 squared. And now I'm going to bring in a useful fact that if you have a squared plus b squared, this is equal to a times b times b. And you can rearrange this to be a times b times a times b, which you can group together to be a times b squared. So a squared times b squared is the same as a times b squared. That allows us to simplify this equation. We can make this instead to be 3 times 10, or 30 squared. And then this can become 7 times 10, or 70 squared. And then this is going to be 33, because the 10s cancel out. And then this will be 83. And that's going to be our quadruple. So the reason why I multiplied by 10 squared is because it was the denominator that I wanted to cancel out. And this useful property allows us to cancel out the tens within the parentheses. I hope that made sense. I multiply both sides by 10 squared. That 10 squared is then able to go inside because of this property, and that allows you to cancel out the denominators and make them all integers. So in the end, what you get is 30, 70, 33, 83. That's the quadruple. And now I have to pull this back. And let's see if this works. 30 squared plus 70 squared plus 33 squared. 6889. If I take the square root of that, that's 83. That does work. So that's how you use the Pythagorean quadruple formula. You plug in values of a, b, and delta, and after scaling up some values and making some of them positive, you are able to generate 4 integers, a Pythagorean quadruple. I think that's pretty cool. So, thanks for watching.